Hello everyone, welcome to Undoubtme. We are back with one more very important video where we are going to prove Thales Theorem. Thales Theorem is also known as Basic Proportionality Theorem. In this theorem, we have to mainly prove that if there is any line drawn parallel to one side of a triangle, like in this case, you can see that PQ is parallel to BC, then it will intersect the other two sides. Other two sides are AB and AC such that the sides are in proportion. Means indirectly, if this is the case, then AP over PB is equal to AQ over QC. This is what we have to prove. So Thales theorem is all about proving these two sides in proportion. Now just to begin with, we have to do some construction. So we will create a perpendicular from Q on side AB, and we can name this thing as N. So QN, I'll write construction, and in construction it is QN perpendicular to AB, and also I will draw PM perpendicular to AC. How this will be used, that I'll let you know in the upcoming part, and then we will join PC and BC. Okay, so we'll write this also, join PC and BC. Now in the proof, we will start with area of triangle APQ. So area of triangle APQ is equal to half AP times QN, and similarly we can write area of triangle PBQ. So PBQ, if you see, it is this triangle. This is PBQ. Now, since this is an obtuse angle triangle, the altitude for this lies outside. So area of triangle PBQ will be half base is PB times height will be QN. In the same way, we will work on the other two triangles, and we will write area of triangle APQ again, but now considering the other altitude as the height. That will be half AQ times PM, and area of triangle PQC will be half QC, QC is the base, times PM. Now here, this is very interesting point to understand, that both area of triangles have some sides which are common. Okay, now to prove this thing, we have to use one more result, and that is that area of triangle which lies in same base and same parallel, they are equal to each other. What do I mean by that? I'll show you over here. So PQ is a base, let's say, and area of triangle PBQ is from PQ. Similarly, PCQ is also from PQ, and they are lying in the same parallel because PQ is parallel to BC. So I can later on use this fact to show that these two areas which I'm encircling, they are also equal to each other. But first, just to continue, let me take it on the next slide and we'll continue it over here. We will be dividing the two black equations, so that will give me area of triangle APQ over area of triangle PBQ, and that will give me half gets cancelled, Q and QN gets cancelled, that will straight away give me AP over PB. Similarly, when I will divide both pink equations, I will get area of triangle APQ over area of triangle PQC is equal to half cancel, PM cancel, it will be AQ over QC. Now let's say this is equation number 1, this is equation number 2. Now just before this only, we have proved that area of triangle PBQ is equal to area of triangle PQC. What reason we will give for this? It will be triangles between same parallel and same base are equal in area. Okay, that's the reason. Because of that, the denominator of both equation 1 and 2 will become same. Numerator is already same. So with all those things, I will come to a conclusion that the right hand side of equation 1 and equation 2 are also equal, and that is how we can write AP over PB is equal to AQ over QC. In this manner, we have proved that if there's a line which is drawn parallel to one side of a triangle, it will intersect the other two sides such that they are in proportion. This was all about Thales theorem, which is also called as basic proportionality theorem. If there is any doubt in any part of this explanation, you can go through the video one more time, and I hope that everyone who has watched this video is clear with it. So you should be able to deal with questions or even the theorem also if it comes in exam. And there are high chances that it will come in exam. So all the best. With a new question in the next video.